Welcome back, boys and girls. So today's class we are trying to learn what we done in our previous week in our classes, proper classes. So here you can easily see this is the chapter 2 from your AP chemistry book, and I'm going to describe and discuss these 2.2 and 2.3 sections of the chapter 2. So starting. Sections of the chapter 2. So starting here, in this says, first of all we are going to describe location, physical properties of electrons, protons and neutrons. And we learned in our class properly that these are called as subatomic particles. These are called as what? Subatomic particles. Subatomic particles. So what are subatomic particles? Simply I can say, or trying to this table, these are particles and this is gonna be the symbol. After that we discussed about the charge, and we also discussed about the mass, and finally we discussed about the location. Okay, so no need to worry about all these are present. I'm just going to discuss these headings and then I will directly show it to you from your AP book and refer the page number as well. So particles mean we are going to discuss about protons, about the neutrons and about the electrons. Symbols stand for the shortest representation that is used by the scientist for anything, specifically for the elements which are they going to use in chemical equations. The charge means what type of the charge, or positive or a negative, or it may have no charge in case of the neutrons. This is the actual mass that is calculated so far, so we must have to remember this. And then the location means where these subatomic particles are located inside the atom. So if I go back to your AP chemistry book, this is your AP chemistry book, you can easily say, or you can easily have a look at what type of these subatomic particles are and what are their charges. Okay, so I'm straightforward going to show you the exact information. No need to go left right, straightforward, stick to your this book. Okay, so here you can see this is the table which you are going to remember. What is this? Electron, proton, neutron, what are their masses, what are their charges? No need to remember these because these coulombs, these charges which are in coulombs, they are provided in your information book or the page which is given along with your exam. Okay, so you have to remember what are their charges and what are their masses. So this is your book. If I place that one there in your notes, so it will become easy. So you have to remember these. Okay, and this is the page number of the book is 48. So if you notice, this is page 48. So now I'm going to paste that here. So instead of that one, you have to remember this. So this information After that we are going to discuss the next part. Next part was about calculation of the isotope. Okay, here describe the location and the physical properties. Physical properties mean you have to remember their charge and their mass. Next point is explain the nature and importance of isotopes. So first of all we are going to define what are isotopes. Very easy, and you remember what are isotopes. Isotopes are the atoms of the same elements. These are what? Atoms of the same element with same atomic number, same atomic number, but different atomic mass. Different atomic mass. Or you may also define it as atoms of the same element, atoms of the same element with same protons but different neutrons. Understood? Next, for example, if I say like we must have to discuss about the representation of the element. For example, I'm talking about the carbon. It has 6 proton and 12 nucleon or atomic mass. Remember that in periodic table this is the symbol. This is what? This is what? Symbol of an element. The next, this one, this number, the number which is bigger one, represents atomic mass. Represent atomic mass. Whereas the smaller value in the representation of an element representing atomic number or protons. This is atomic number or protons. Now the next, if I say C6 and 13, so you can easily compare. These are the same element. Why their symbol is same? Because both belongs to the carbon. If the symbols are different, again no need to worry about, just focus for their atomic number, which is the main identity of an element. So you can see these two are same. These two are same, mean their atomic number is same, whereas their atomic masses are different. That is why these two atoms or the particles belongs to the same element. They have same atomic number, but their masses are different. Their atomic masses are different. Another one is C6 and 14. So now you can again easily compare. These numbers are same. These numbers are which are atomic number. As I clearly mentioned, the smaller number written along with the symbol of an element is always atomic number, whereas this bigger number, whether or no need to worry about the position. Okay, either it is written below, left, right, no need to worry about. The bigger number is always atomic mass. The bigger number is atomic mass, whereas the smaller one is the atomic number. So atomic number are same, but the atomic masses are different. That is why they are the isotopes. Now let me explain how to calculate these subatomic particles. Okay, calculation of subatomic particles mean calculation of proton, neutrons and electrons. Okay, particles. So for example, I'm focusing for this particle C6 and 12. So as I clearly mentioned, protons are always equals to atomic number. Proton always equals to atomic number in any atom. So in this specific case, we can say this is 6, whereas the neutrons, these are what we can say neutrons. We must have to subtract the smaller value from the bigger one. The atomic number must be subtracted from atomic mass. So atomic mass, and we have to subtract atomic number. This is the formula. Furthermore, one more thing which we have to discuss. The 12, which is the atomic mass, is always represented by letter A, whereas the atomic number is represented by letter Z. Okay, so we can clearly mention this A minus Z here. Okay, to memorize, to remember. Now, as the bigger number, the atomic mass is 12, the atomic number is 6, so the answer is 6. So in this way, we learned that how to calculate different subatomic particles. Last one is electrons, and remember, electrons are always equals to protons because the atoms are electrically neutral. Atoms are electrically neutral. So why and how I can explain this? Simply remember, as I said, the protons and electrons are same. So proton is positively charged, whereas electron is negatively charged. So they will cancel out the effect of each other. As there are 6 protons, means 6 positive particles, whereas 6 electrons which are negatively charged, so they will cancel the effect of each other and the atoms become overall neutral. Atoms are overall neutral. So remember these. Atoms are neutral. Why? You must learn how to explain. I'm repeating this again. If the protons and the electrons are same in number, but we know they have opposite charge, that is why they cancel out the effect of each other and they are neutral. Next we are going to discuss the chemical properties. Remember that chemical properties of isotope or anything, okay, elements sorry, of elements. Specifically we are discussing about isotopes. Depends mainly on electrons and protons, or more specifically I can say outer shell electrons. Outer shell electrons. So as the outer shell electrons are same, okay, that is why as outer shell electrons in isotopes are same, therefore isotopes show same chemical properties. So I think you understand that. So we will discuss the next points from the learning objectives in our next video. Stay tuned, take care, we'll see you, and I will upload the next